So now we're going to do some of the two-step calculations. Again, we're going to introduce dimensional analysis first, showing how you can use it to do multiple steps. For instance, if you wanted to calculate how many seconds there are in an hour, you can say that there are 1 hour, x, line, drag down the unit, just like we always did. I asked for seconds, but you might not know this conversion already. So you have to convert hours to something you do know, such as minutes. And we know that the conversion to minutes is 1 hour is 60 minutes. And so I asked for seconds, so we need to keep going. So it's another x, another line, another drag down unit. I asked to get to seconds, and so now you have to look and say, well, how do I get to minutes to seconds? And so it's just like the one step, except that it is more than one step. 1 minute is equal to 60 seconds. You can still draw your diagonals, where my hours, cross that with hours, minutes with minutes, seconds is left over. I still multiply the numerators, 1 times 60 times 60, divided by the denominators, divided by 1, divided by 1, and you get 3,600 seconds. And so it's more than one step, but it's the same process again and again. And you could do this longer, converting seconds from years or meters to kilometers to miles to feet to inches to anything possible. You just would keep repeating the process, keep doing known conversions until you get what you're looking for. So here we're going to look at molecules from grams. And so you start with what's given to you, 25.0 grams NH3, X, line, drag down the unit, grams NH3, and the question is asking for molecules. Unfortunately, we don't have a conversion to go from grams to molecules. It would be different for every element, for every molecule, for every compound. I'm sure you could look it up someplace, just like you could look up 3,600 seconds to an hour. But we don't have that. That's not on the yellow PT. That's not something that we can do quickly. So what we have to do is convert to something we do know, which is moles. How to convert grams to moles. And you convert to grams to moles using the molar mass. And so the molar mass of NH3 ammonia is 17.0307 per 1 mole. If I have 1 mole of ammonia, NH3 molecules, it would weigh 17.0307 grams. Question asks for molecules, so I need to keep going. X, line, drag down the unit, moles of NH3 to molecules. Now this is a conversion that we are able to do. And so 1 mole is equal to 6.02 times 10 to the 23rd molecules. Again, you can draw your diagonals. Grams, grams, moles, moles, molecules. You can now type the numbers into your calculator. One long equation is far better than doing, say, 25 divided by 17.0307, have some type of intermediate number, and then multiplying that by the 602 times 10 to the 23rd. It's much, much better to have one long equation. Only press the equal button into your calculator once. You don't want to transcribe incorrectly from the calculator to the paper to the calculator again. You can round for sig figs at the very end. You'll notice this answer, I kind of did this on purpose in terms of my agreed answer and what your calculator says. I think the calculator says 8.84 in terms of 3 sig figs. That last decimal place, that last significant figure, that can be a bit off. Perhaps we rounded here a bit differerly from different PTs. Maybe you did round intermediately. Maybe the 602 number, there's more precision behind there, 60221366736. You can have a whole bunch of trailing numbers back there. So as long as you're very, very close, things are going to happen where you can still be right. 8.84 is very close to 8.85. Being halfway there or off on a different magnitude of scientific notation, that would be bad. 7.84, that would be bad. 8.54, that would be bad. But 8.84 is very close to 885, so that is okay. So this is again converting grams to molecules, and it does take a couple of steps. I'm going to do another problem with you, maybe go in the backwards way, and backwards in relation to number one. Instead of being given grams and asking for molecules, this one we're given molecules asking for grams. So still the same process. Write down the number that's given to you, 820 times 10 to the 22nd molecules. It's good to label the units every time possible. X line, drag down the unit. No guessing as to what unit goes top or bottom. It's not an always moles on top, moles on the bottom. X line, drag down the unit. Questions asking for grams, but we don't have conversions. We don't have a number to go from grams to molecules. And so you're going to have to do moles, which is typically what we will be doing, converting towards moles or away from moles again and again. This is a conversion we know to be true. 1 mole is equal to 6.02 times 10 to the 23rd. Molecules goes away, and I'm left with moles. The question asks for grams, so I need to keep going. X, line, drag down the unit. Trying to get to grams. This is something that we do know. Grams to moles. 1 mole is equal to the molar mass of this dinitrogen hexaoxide molar mass. I happen to know it's 789.414 equals. And again, moles cancels out with moles. I'm left with grams. That's going to be my answer there. Type this into your calculator, which I'm doing now. And you end up with 107.5. Again, we're going to be 1 sig fig off my given answer to 3 sig figs, but the one last sig fig is 1 off. That's very close. That means we solved the problem correctly, just somewhere rounding, either with the answer key, with my calculator, with your calculator. We're a little bit off, but it's still an accurate number that can be relied upon. And so when you type this into your calculator and you get 108 as opposed to 107, that's a good thing. 120 would probably be too high. 53 would be bad. 0.107, that would be bad. Should still be the same order of magnitude, and should be very close to the accepted answer that's in bolded in parentheses. So this is what you'll be doing again and again. X line, drag down the unit, but notice it's different numbers every time, different order sometimes. It does take some practice into being able to do this. And so go ahead and practice, that's allowed. Review your notes, your book has good tutorials. These screencasts will help you, and again, you're capable of doing this. Thank you.